All right, so guys, today we're going to learn about classifying triangles and then angle measurements also of triangles, okay? So hopefully we know what a triangle is, right? It's a figure formed by three segments joining at three non-collinear points, and those points are called vertices, right? Oh, I'm on frozen, sorry guys. Okay, so three non-collinear points, and those are vertices. Okay, there's a few ways we can classify triangles. One of them is by their sides. And so in a minute, I'm going to show you what each one is. But if we're classifying triangles by their sides, we have equilateral triangles, we have isosceles triangles, or we have scalene triangles. Okay, so let's look and see what those each are. So an equilateral triangle, all three sides are going to be congruent. Okay, so their length measurements are going to be equal. Sometimes they don't tell us that, and you'll just see the tally marks. Since all three of these have one tally mark, that tells me that they're congruent. Okay? So if I knew one side, I would know all three. Okay? So that's one way we can classify a triangle. Equilateral triangle, all three sides are congruent. An isosceles triangle, at least two sides are congruent. Okay? Again, you'll see they use two tally marks here, and then there's two tally marks here. That tells me, since they're both two tally marks, that this side is equal to this side. Okay? And then the last one for sides is a scalene triangle. A scalene triangle has no congruent sides. So none of their sides are equal. So let's try and classify some. So if I look at the top left, how many sides are equal? On the top left. And you have a copy of this PowerPoint on Google Classroom too. Oops, let me go back. I was trying to zoom in. I don't think it lets me zoom in. So it's 5, 5, and 6. So we have two sides that are congruent. So what kind of triangle is it? Isosceles. Okay. If I go to the right, I have 19, 19, 19. What kind of triangle is it? Equilateral. Good. If I go to the bottom left, I have 6, 8, and 10. Scalene, because none of them are equal. And then the last one, I have 5, 10, and 12. Scalene also. Okay. So that's classifying triangles by their sides. Not too bad. We can also classify triangles by their angles, though. And the ones we're going to learn are equal angular triangle, acute triangle, right triangle, or obtuse triangle. Let's go through each one of those, okay? Equal angular, it's kind of in the name. All three angles are going to be congruent, okay? So all three angles are going to be congruent. So that's why they all have one tally mark at the angle, okay? Now, some of you, when we did the pre-assessment, you remembered that all three angles of a triangle must add up to what? Some of you did it right. 180, good. So all three angles in a triangle have to add up to 180 degrees. So if all three are equal, what must each one be? They all three have to be equal. So 180 divided by 3 gives me 60. So 60, 60, 60. So an equal angular triangle must have all angles are equal. Well, we know that that must mean they're 60 degrees, okay? Because they have to add up to 180. An acute triangle, all 3 angles are acute. So if you remember, acute means they're less than 90 degrees. So all 3 angles must be under 90 degrees. And then the triangle is an acute triangle. A right triangle, just one angle needs to be right. And that's 90 degrees, right? So a right triangle means 90 degrees. So where you see the little box, that means 90 degrees. And it makes sense that only one can be 90 degrees because that means these two have to be under in order for them to make it, okay, to 180. And then the last one is an obtuse triangle. Again, only one of the angles has to be obtuse. And that makes sense because if all 3 add up to 180, you can't have all these obtuse angles. You can only have one, okay? All right, so let's try and classify them. So the green triangle, well, we kind of went over that one, is what? If we had to classify it. We call it equal angular when it's the angles, but yes. But you are correct, and we'll go through that later, but yes. Okay, the top right, I have a 40-degree angle, a 20-degree angle, and a 120-degree angle. What kind of triangle is that? Obtuse, because one of them is more than 90 degrees. And then the one below it, I have 78, 80, and 22. Acute, because all 3 angles are less than 90 degrees. Okay. Okay, this part is really important, especially for some later lessons that we're going to do. So we talked about all the points on a triangle are the vertices, or one of them is a vertex, okay? From a side, I'm sorry, let's go back. From a vertex, that gives us an angle. So we have angle A, angle B, angle C in this example, okay? If I'm standing at angle A, so like if I'm a little person and I'm standing here at angle A, and I want to know what side is opposite of me, I'm going to walk across and I'll see what side is opposite from me. BC. Okay? And so it's going to be important to know what side is opposite from what angle. Okay? Because as we learn some more rules, this part is really important. Okay? So if I'm at angle B, for example, if I'm standing at angle B and I walk opposite, what side is opposite from B? So if I'm standing at angle B and I walk opposite, I'm at what side? AC. And then the last one, if I'm standing at angle C, what side is opposite? AB or BA. Yeah. Okay. And it didn't matter what order you put the letters in because they're both a vertex. So you could say AB or BA and you're correct. Okay. Okay, that's kind of what I already said. Sorry. All right, so let's try it again. If I'm standing at angle J, what side is opposite of J? Good, LK. And if I'm standing at angle K, what side is opposite? Did I hear it? I don't know. LJ. Okay, so if I'm standing at K and I walk across, it's LJ. Another way to look at it, guys, is LJ is the only side not connecting to K. Do you see that? So see how LK and JK, they connect to K? This one doesn't have a K in it, LJ, and so that means that's why it's opposite also. So if you get confused, if the triangle gets too big or something, okay? So angle L, what side is opposite? Good, JK or KJ. Okay. So this one we already talked about, but I don't know if you knew that it had a name. So we did say that all the angles inside of a triangle must add up to 180 degrees. The name for this is a triangle sum theorem. So if you see that word on a quiz or a test, just know that all it means is that all the angles in a triangle add up to 180 degrees. Triangle sum theorem. Okay. In geometry, we don't like to write things out. Remember, we like to use symbols. And so the way to write the triangle sum theorem in geometry is we're going to say triangle, so there's a little triangle, A, B, C. So these are the vertices. A, B, and C are the vertices. And if we're talking about the actual triangle, we put a little triangle in front of it. Okay? So we know that triangle ABC, that's the one we're talking about. We know that the measurement, so that M in front of there means measurement. Measurement of angle A plus the measurement of angle B plus the measurement of angle C equals 180 degrees. Okay? So instead of using words, we like to write down the symbols with the angles. If it's got an M in front of it, we're actually talking about the measurement. If I'm just naming it, if I just want to say angle A, then I don't have to put an M in front, okay? So if I'm actually just naming it, there's no M in front. If I'm talking about the value or the measurement of it, that's where the M comes in. Okay, so let's try and find the missing angles based off the triangle sum theorem. So we know that all angles add up to 180, or all three angles, okay? So the first one, we have missing A, we're missing angle A. We have 25 and 15. So I want to do 180 degrees minus the 25 minus the 15. And so what am I left with for angle A? Well, what is 25 plus 15? What's 25 plus 15? 40. What's 180 minus 40? 140. So angle A is 140. Okay? All right, let's go down. We have 61 degrees and 59 degrees. Okay? 61 plus 59 is what? 120. 180 minus 120 is equal to what? 60. So angle A must be 60. So if angle A is 60, angle B is 61, and angle C is 59, do you agree that this is also an acute triangle? Because all of them are under 90, right? Okay, this one's kind of special. We have a 56 degrees plus 34. What does that give me? 90. What's 180 minus 90? 90. So I know that angle B is 90 degrees. Remember, if one of our angles is 90 degrees, it's a right triangle. So this one's special because it's a right triangle, okay? And again, we're going to learn more with right triangles. They have some special rules that we do, okay? And then this is kind of what we talked about, but let's put it in words. So corollary to the triangle sum theorem. Okay, that's just some fancy words, but basically it means that the acute angles that are not the right angle, right? So we agree that C is the right angle in this case, so that's 90 degrees. The other two angles, right? The two that are not the 90 degrees, those are acute angles, and their sum must be 90 degrees. Agreed? Because then the whole thing has to be 180. So what that means is angle A and angle B are complementary. Because complementary means the sum adds up to 90 degrees. Okay? So we did learn complementary a few chapters ago, but I want to bring it up again. So complementary means the two angles added together are 90 degrees. If this one's already 90, then these two must add up to be 90 so that all three add up to 180. Okay? And again, in geometry, we write it as measurement of angle A plus the measurement of angle B would equal 90 degrees. So let's find the missing angle. If we know this is 90, the shortcut is these two must be 90. So all we have to do is 90 minus the 17. Do you see that? So what do we get? 90 minus 17, we get 73. So this one must be 73. All right, the top right. This one is 90 degrees, so these two must add up to 90 degrees. So if this one's 65, all I have to do is 90 minus 65. So what is A? 25. Okay, this one's kind of special. If C is 90 degrees and B is 45 degrees, again, B and A must add up to 90. What's 90 minus 45? 45. So now we have 45, 45, 90. Okay, this is going to be a very special triangle later. And it's funny, it's actually called special triangle, but we'll learn that later. But just know a 45, 45, 90 is a special triangle. And that's going to come up later in another lesson. Okay. Okay, last part of my notes. If I have a triangle, the original angles that are inside the triangle are called interior angles, okay? And that makes sense. Those are those red ones right there. Now, if I extend my sides, right? So if I extend my sides out, it's going to create some extra angles, right? So all of a sudden you can see that there's some extra angles going on over here if I extended the sides. Okay. Those extended angles are going to be exterior angles. So those are those yellow ones right there. Okay. Now I want you to look at this. If I'm talking about angle A, like on the inside where it was red earlier. So if I talk about angle A, the red, and angle A, the yellow, the exterior, does anybody notice that those are next to each other and they're making a line? So what are those? So I'll say it again. This little angle here, it was red, and then the yellow. Those two angles have a relationship. They're linear pairs. Good. Okay. So we're not done with linear pairs. Okay. So the angle that's adjacent to the exterior angle to the interior angle will be the exterior angle. Okay. It has a common vertex, so they both have A. So you have to be careful when you say angle A, because I'm going to be like, well, are you talking about the yellow one or are you talking about the red one? Okay. Now, what's special about these? Well, we just said that if they're next to each other, they're linear pairs. Okay. They also have a really interesting rule where if I have angle A and angle B, the interior angles, the sum of those will equal this outside angle. Okay, let me say it again. So angle A plus angle B, those are the interior angles. The sum of those two will equal this outside angle 1. Does anyone see why? So you guys agreed that these were linear pairs, right? So if these are linear pairs, then angle 1 plus this angle C inside have to equal 180, right? Well, 180 minus this one has to be the sum of these two. Don't you agree? Because all three inside angles have to be 180 degrees. Do you see it? Or do you want me to say it again? Okay, so think about just the inside angles. A plus B plus C have to equal 180 degrees, right? But then we said angle C, the inside, and angle 1 on this outside have to equal to 180. So if these two add up to 180, that means 180 minus C gives me this angle, right? Well, that means these two have to equal this one because they all add up to 180. Okay? So how do we write the rule? The rule is the exterior angle will equal the sum of the two remote interior. Remote interior means the ones across from it. So angle 1 is going to equal the sum of angle A plus B. So let's try one so you can see it. Okay, so this angle is 131 degrees. Okay, this outside angle. We're trying to find angle 1, and we know that this angle is 112. Okay, but the rule says that the remote interior, so the two that are across inside, the sum of those two equal this outside. So all we have to do is 131 minus the 112. And so we find out in this first example, angle 1 is 19. Okay, if angle 1 is 19 and this angle is 112, what must the third angle be, the inside one? Well, it'd be 180 minus 131, and that equals 49. So this angle inside would be 49. Do you agree that 49 degrees plus the 131 are 180? Yes. So these are linear pairs. And then we also said that this angle and this angle have to equal this angle, okay? Let's try another one. Let's try this one. This one will show it better. Okay, this angle is 90 degrees because it's a right angle. If this is 90 degrees and this is 20 degrees, what's 90 plus 20? What is it? Okay. So 110 equals angle 1. Okay? But what's the missing inside angle? Good. And then do you agree that this 110 that you just told me plus this 70 equals 180?
Yes.
Yes. So these two next to each other are 180. And then the inside ones are 180. So that means that this one plus this one has to equal this outside one. Okay, hopefully it's connecting a little better. And then the last one's just kind of tricky. What kind of triangle is this? Equal angular. So what must this angle be? 60. Okay, now there's a couple ways you can do it. We know that this is 60 and this is a linear pair. So what must this be? 180 minus 60 gives me what? 120. What's the sum of the two across from it though? 120. Okay, so it all connects. Okay, we're gonna do mule tube, and then we have some classwork to do, but we do have a mule tube too, okay?